this is a tutorial to help you finish as the graphing quadrilateral activity. So the first quadrilateral is quadrilateral card, so we need to plot the points. Two, 7 is C. 5, 10 is A. 10, 5 is R. And 7, 2 is D. Alright, and we're going to connect all 4 points with a straight line. And we mentioned earlier that card was a rectangle. I'm going to take a picture of this so that I can use it for the next part of the lesson. Alright. I don't know why those lines were included on the photo, but hey, it is what it is at this point. So to find the length of segment CA, or to find the length between any 2 points on a grid, you can use Pythagorean's theorem. But you would have to create right triangles. So you have to get from C to A by making a right triangle. So you have to go up. Oh gosh. I want them to be straight. So I'm going to use the line tool. Alright. Go up and over. And in the process of doing that, you can count how many times up was 3 and how many times over was also 3. So we're looking for the hypotenuse of this right triangle. So it would be the square root of 3 squared plus 3 squared. I'm just going to go back and double check that that's correct. 3 up, 3 over. Yep. So that means it's the square root of 9 plus 9, which is the square root of 18, which you would have to simplify that root. branching it off, it'll be 2 times 9, and 9 is 3 times 3. So it would end up being 3 square root of 2. All right. Now we got to find the length of CD in the same manner. We're going to use Pythagorean's theorem. We got to form a right triangle to get from C to D. So we go downwards and across. And we went down 1, 2, 3, 4, 5, and over 5. Hey, all of y'all are in my recording, so keep it down, please. Alright, so it would end up being the square root of 5 squared plus 5 squared, which would end up being square root of 25 plus 25, which is the square root of 50. And then you would have to simplify the square root of 50. Which would be 2 times 25, and 25 is 5 times 5. So it'd be 5 root 2. That's a negative. Little Perry, that's a negative. Alright, it's looking for the diagonal AD, so let's put it on the picture. So here's diagonal AD. So we need to find the length of that in the same manner using a right triangle, but technically AC is part of the triangle and CD is part of the triangle, so we just need, you can count that, but those aren't straight, so that would be a little difficult to do. So we're not going to go that route. So we'll form a right triangle by going across and down, just like so. So I went across 2, and downwards 1, 2, 3, 4, 5, 6, 7, 8. So for AD, it will equal the square root of 2 squared plus 8 squared, which is 4 plus 64. So that's the square root of 68. So we got to branch off and factor 68 now. I know 2 goes into 68 34 times, and 34 can be broken up to 2 times 17. So it would end up being 2 root 17 for AD. For diagonal CR, I gotta put it on the picture first. And form a right triangle now. All these triangles are getting confusing. That's one reason why I don't like this method, because it starts cluttering up the picture, but if it works best for you, that is totally fine. So to get from C to R, you go downwards 2 and across 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be the same as AD, which is 2 square root of 17, because the right triangle had the same sides, 2 and 8. So there's no point in going through the process of everything if you already know the triangles have the same two sides. So the next question said, how did the diagonals compare? I just answered that for you. They're the same. They have the same length. All right. Now I need a clean picture because I need to for you to see the rest of the pictures. Ooh, I can move that. Great. Now, okay. Oop, I don't want to move that. I do want to delete all of that. I want to delete that. All right, let's put this back over here. Beautiful. Alrighty, now it wants us to find the measure of ACR, so I'm going to highlight that. A, C, oh, I should have left my diagonals on there. Okay, there's one, there's two. So ACR trails along the diagonal, so it's not the entire corner. It's essentially this angle right here. At the end of the day, ACR is that angle. So we know the length of AC or CA is 3 root 2. And we know the length of CR is 2 root 17. This is a right triangle because it's a rectangle. So we have to use trigonometry to find the angle. When I look at get the respective angle, I have the adjacent side and I have the hypotenuse. So I can use cosine. So it would be cosine of the angle. I don't know what it is, so let's call it x. It's equal to adjacent, which is 3 square root of 2, over hypotenuse, which is 2 square root of 17. And then, since I'm looking for the angle, I have to use cosine inverse to get x by itself. So x is going to equal cosine inverse of 3 square root of 2 over 2 square root of 17. And then we grab our calculator and type all of that in one step. So let me grab my calculator. I'm going to need a really big scientific calculator. So I'm going to Google one, which is what some of y'all can do as well if you don't have your own TI. And on this computer, I don't. And Web 2.01 is pretty darn nifty. Free, free, free. Alrighty. So I need second cosine. And then you need to unclick second in order to type the thing again. And then I need parentheses. What was it? 3 root 2. 3 square root. Oh gosh. All right, back up, back up. I need to do the square root first of 2, close parentheses, times 3. I need to put that in parentheses. Divided by parentheses square root of 2 times, no, it wasn't the square root of 2, it was square root of 17. 17 times 2, close parentheses, you need a lot of parentheses using a calculator that's not the TI. So I want to second, cosine, all of that. Boom. And that would equal about 59.0 degrees. About 59 degrees. That's a lot. Again, if you had the TI, it would be so much faster. But if we don't have the TI, we have to use our resources wisely. So the angle is about 59 degrees. Now it wants us to find the measure of this other angle, so I'm going to erase my markings. Okay. Now we're going to look for angle DCR. So we're looking for this angle in the corner, right here. Now, it wants us to use trig. So we know the measure of CD as 5 square root of 2. We also know that CR again is 2 square root of 17. So we have adjacent and hypotenuse. So we must use cosine again. So the cosine of x is equal to adjacent, which is 5 square root of 2, over the hypotenuse, which is 2 square root of 17. And then you must inverse that. So it would be x is equal to cosine inverse of 5 square root of 2 over 2 square root of 17. And you put it in your handy dandy calculator, and it'll be approximately 31 degrees. All right, so I'll work out number 6 with you completely, just for extra practice, and just tell you the answers for the rest. But you still need to know how to show the work. All right, so for quadrilateral best, let's plot the points. B is at negative 11, 2. 2, so B would be here. E is at negative 9, 7. S is at negative 3, 11. and then negative 5, 6 for t. Connect it. And we already mentioned earlier that this was a parallelogram, just a general parallelogram. So I'm going to take a picture of it for the next page. Alrighty. So the first thing I would like for us to do is find the length of segment BE. So again, we're going to use Pythagorean's theorem to form right triangles. So to get from B to E, I need to go upwards and over. And I went up. 1, 2, 3, 4, 5, and over 2. So BE is equal to the square root of 5 squared plus 2 squared, which is 25 plus 4, which is 29. And that's prime, so I have to stay root 29. Now for ES, form my triangle, go upwards and over. I'll go over up. 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6. So ES is equal to the square root of 4 squared plus 6 squared, which is 16 plus 36, which would give us 52. And then we can, let's see if we branch that off. If you can simplify, I know 2 times 26 is 52. And then it'd be 2 times 13 is 26. So you can break into 2 root 13. This is all good practice for your futures, ladies and gentlemen. So please practice how to simplify these radicals. Do not just put it in the calculator and get decimals. It's all helpful to you. All right, I need to draw all these diagonals that are mentioned. The first one is ET, and I need diagonal BS as well. It wants the length of each of those first. So for ET, let's do that one first. To go from E to T, I go downwards and over. It went 1 down, and 1, 2, 3, 4, 5 means the distance from E to T is equal to the square root of 1 squared plus 5 squared, which is 1 plus 25, which is 26. And 26 breaks apart into 2 and 13, so it won't simplify any further than that. So you're going to have the root of 26. Now for diagonal BS, to go from B to S, you go over 1, 2, 3, 4, 5, 6, 7, 8, and up 1, 2, 3, 4, 5, 6, 7, 8, 9. So for BS, it will be equal to 8 squared plus 9 squared, which is 64 plus 81, which would give you a 145. And if I divide 145 by 5, you'll be left with, it goes into 14 twice, leaving 45, so 9, so 29. 5 and 29 does not, are both prime, so it doesn't go any lower than square root of 145. Alrighty. It now wants the slope of the diagonals. Slope, there's a formula for slope, which is y2 minus y1 over x2 minus x1. Slope is also equal to rise over run. So for ET, it fell down once, so that's a negative 1 down, and it ran 5. So the slope is negative 1 over 5. To go from B to S, it rose 9 and it ran 8. So the slope is 9 over 8. So those same numbers from my right triangles will also help find your slope. You just got to remember if you have to go downwards from left to right, you need to make sure it's a negative slope. And you always read from left to right. So if it's going upward, it's going to be positive. If it's going downward, it's going to be negative. All right, there's a correction. On ET, I went over 4, not 5. So the slope is negative 1/4, and that's going to change my length as well. So it'll be 4 squared, which is 16, and 1 squared would make this 17. So it ends up being the ET is the square root of 17. All right. Now that that's done, again, make sure you show your work on how you get these answers, but to help you and to let you know that you're on the right track. Number 7, the slope of the diagonal low is 1. For HW, it's -1. For the length of HL, you should have 4. For OH, you also have 4. The length of the diagonal LO should be 4 square root of 2. And for P, for the diagonal PN, you should have the square root of 41. And it is possible where I might have made a mistake because I went pretty fast. So please let me know if you think I made a mistake. The length of diagonal GI is 5 root 2. The slope of diagonal PN is -4/5. And the slope of diagonal GI is 1/7. This concludes your tutorial. I hope this helps. Again, you're going to have a major grade over this content, so you need to know how to do this all on your own.